So if we create a list of iShape, let me back up a minute. So if we didn't want to use the interface, how would we create a list of all these shapes? You have to create a list for circle, a list for triangles, and a list for squares. And never shall the 2 or 3 intersect. They all have to be completely unique collections in order for you to manage all these different types of classes or types of objects. Instead, by using the interface and by implementing the interface, we can put them all into one big collection because they all are part of that same club. So by doing iShape as a list, we can say shapes.add new circle, shapes.add new square, shapes.add new triangle, and then maybe I'll just mix it up. Okay, so I have this collection now of shapes. I'll make one more quick modification. I'm going to take name and make it a get only. And then I'm going to modify each one of these to return its name. So I don't have to assign it. So then if I do a for each, and then I'll say console write line item.name, where this is an iShape. And then console read, just so it pauses, otherwise it will exit automatically. Of course it doesn't work. Can I be assigned? No. So this no longer works, because I changed that. F5. So we now have this collection, this uniform collection of all these different shapes. So we can put circles, squares, triangles, all these different things into that one collection. You don't have to have a collection of circles and a collection of squares and a collection of triangles. So let's say, for example, you're building an e-commerce site, or an e-commerce app, or some sort of sales app. And you're selling different types of products. Those products have unique properties. You're selling sporting goods, and you're selling food, and you're selling electronics. Those different types of item kind of serve the purpose of needing their own type of class. A piece of sporting equipment does not have the same properties as a motherboard. The things you use to describe a baseball are not the same things you use to describe a hard drive. So you'd want to build a different class to represent each one of those things so that you can get the most amount of detail possible. But when you create something like a shopping cart, you want to be able to put the hard drive in and the baseball. So how do you make it so that you have products that all fit in the same shopping cart? You don't want to have a shopping cart for hard drives and a shopping cart for baseballs. You create an interface of product. What do all products have? A name, a price, maybe a short description. Depending on how you do it, maybe you have quantity in stock. And you define all that in your iProduct interface. Mm-hmm.
Can you just use inheritance?
You could. For what I just described, you could use inheritance. So you could create a base class of product and then inherit everything off of that. there are definite pros in that particular scenario. So let's take that one step further. Let's say that you're building an application that allows third parties to come in and add products to your store. That third party can implement an interface, but they may not be able to inherit your base class. Because your interface is nothing more than, this is how you interface with this, or how I will interface with this class. It doesn't care how you implement that class, but it wants to know that these points of communication, these properties, these methods are available. So there's one, not debunking, but one case where simply inheriting a class wouldn't work. Another scenario is when you have your application and you're developing for it to connect to a particular database. Your database implementation, so if we go back into the .NET Framework itself, under system.data, you have IDB connection. Now, if you were writing any sort of database data layer, database driver, if you want to think of it that way, and you were writing it for the .NET Framework, you would want to write it so that it implements this interface. So what does that do for you as a developer? What does that do for the developers that would use your driver? One, you're now aligning with a consistent architecture that most developers should be familiar with. If they've written it for SQL, then they should be able to write it for your database. Oracle, MySQL, Postgres, any of those. So that's one win. Two, I can now build my application where all of my connection variables, my command variables, my data reader variables, those are all of this interface type. So what does that do for me as the one writing this program? I no longer have to worry about what kind of database I'm connecting to. As long as my database connection uses these interfaces, those objects, those classes, all I have to do is create variables that are IDB connection, and then I just worry about it feeding me the appropriate classes kind of under the hood. So you start to build this plug-in type architecture where things can become dynamic, where they're not so reliant on base classes. And base classes kind of put you into this hole potentially because depending on what you're implementing, most of the time base classes are good, okay? Let me make that statement. It's not a bad thing. But if you want to have a great level of flexibility, the interfaces give you the capacity to not make everything dependent on a base class. They can all work and stand completely independent. Plus, with a base class, you can only inherit one base class per drive class. So if you have pieces of functionality that you want a class to implement, you can't put all those different pieces inside of different base classes and then inherit all of them. You can only inherit one base class, but you can implement multiple interfaces. So let's kind of go in a different direction and let's do a different kind of example. I want to get to the database thing, but I think that's still too early.